Normal sinus is thus named because the electrical impulses that start the contraction is initially generated in the sinus node, and it then follows the normal conduction pathways through the heart. In this example, we are going to use a slightly simplified approach to rhythm recognition to get us started. The first thing I'm going to do is label the P waves, QRS complexes, and T waves. While the QRS complex is normally easy to identify, recognizing which bump is the P and which is the T wave can be confusing for beginners. We can see from this ECG that the P and T waves have slightly different shapes, the T being both taller and wider than the smaller P wave. If you don't feel confident recognizing the P, QRS or T waves, or don't understand what they represent on the ECG, you may want to go back and have a look at the first video in this series. I'll leave a link in the description below. The next thing I want to do is work out the rate of the ECG, e.g. how many times the heart beats per minute. I can do this by looking at the grid of squares that make up the ECG. We can see that the ECG is divided into large squares and small squares, 5 small squares making the length of one larger one. To start with, I only want to look at the large squares, so I'll remove the smaller ones to keep things simple. As we discussed in the previous video, the horizontal axis on the ECG represents the passage of time. Each large square in fact represents the passing of 0.2 seconds. Along the top of my ECG, I'm going to count off 30 of the large squares. 0.2 times 30 large squares equals 6 seconds. I am now going to count the number of QRS complexes in this 6-second 30 square period. We can see that there are 8 QRS complexes. As each QRS complex represents one contraction of the ventricles, we can say that the heart has beat 8 times within this 6-second period. Multiplying 6 seconds by 10 will give us 60 seconds, e.g. a minute. Therefore, timesing our 8 QRS complexes by 10 will give us the number of QRS complexes in a minute, in this case 80. We can say that the heart is going at approximately 80 beats per minute. A normal rate is considered anywhere between 60 and 100 beats per minute. We can therefore say that this ECG shows the heart beating at a normal rate. So to recap, to get an approximate beat per minute for our ECG, we count off 30 of the large squares, count the number of QRS complexes within the 30 squares, and then times this number by 10 to get our beats per minute. Next, I want to know if the rhythm is regular. When the electrical conduction system is functioning normally, the sinus node will produce electrical impulses at very regular intervals. If the rhythm we see is irregular, that tells us straight away that something is amiss. The easiest way to find out is to mark off the peaks of a few of the QRS complexes. You can use a scrap of paper to do this. If the rhythm is regular, then we should be able to move the marks we have made further down the rhythm strip and still have them match the peaks of the other QRS complexes. E.g., as we move down the strip, we should find that all the QRS complexes are regularly spaced. We can see that the complexes on this ECG are evenly spaced. It is regular. The next thing we're going to check is that a P wave precedes every QRS complex. In normal sinus, the atrium, represented by the P wave, contract first, followed by the ventricles, represented by the QRS complex. If we were to see on our ECG that there were, for example, several QRS complexes in a row without a P wave, then we would know that we probably weren't looking at a sinus rhythm. Likewise, if there are multiple P waves without a QRS, then that would also tell us we were looking at an abnormal rhythm. On our ECG, we can see that each QRS complex is preceded by a P wave, and every P wave a QRS complex. The PR interval represents how long a pause the atrioventricular node produces in the flow of electricity from the atrium to the ventricles. If the AV node is functioning as it should, then it will produce only a short delay, enough time to allow the atrium to fully contract, ejecting all its blood into the ventricles. If the AV node is not working properly, however, then the pause may become longer, or in some cases it may block the flow of electricity altogether. Complications with the AV node are known either as heart blocks or AV blocks. To measure the PR interval, we are going to use the small squares on the ECG paper. Each small square represents approximately 0.04 seconds. We measure the PR interval from the beginning of the P wave to the start of the QoS complex. A normal range is considered to be between 3 to 5 small squares, or 0.12 to 0.2 seconds. A PR interval that is longer than that represents a heart block. On our ECG, the PR interval is approximately 3 small squares, so falls within normal range. The last thing we're going to look at is the width of the QoS complex. This tells us something about how the electrical impulses are travelling through the ventricles. When the conduction system is working normally, then the impulse will flow through the bundle of His and down the left and right bundle branches. These conduction pathways transmit electrical impulses very quickly. We would therefore expect the QoS complex to be narrow. During some dysrhythmias, however, the impulses do not follow the normal conduction pathways. For example, if an electrical impulse is produced somewhere within the right ventricle, rather than travel along the conduction pathways, it will travel more slowly from cell to cell to cell, across the right ventricle and then the left. This will take longer, so the QoS complex will be wider. When measuring a QoS complex, we again use the small squares on our ECG paper. A normal, narrow QoS complex is considered to be less than 3 small squares. That means that it takes less than 0.12 of a second for the ventricles to contract. A QoS complex that is wider than 3 small squares is considered to be wide. Examples of dysrhythmias that produce a wide QoS complex include ventricular tachycardia, ventricular fibrillation, and bundle branch block. We can see that on our ECG, the QoS complex is less than 3 small squares wide, and so can be considered normal. And so we have our normal sinus rhythm. The heart rate is between 60 to 100 beats per minute. The heartbeats are produced at regular intervals. There is a QoS complex for every P wave and a P wave for every QoS complex. The PR interval is between 3 to 5 small squares, and the QoS complex is narrow. All is as it should be. To finish, as I mentioned at the start of this video, we have used a slightly simplified set of steps to interpret this ECG. Other resources you may look at will probably include a greater number of steps. For example, we have not looked for ST elevation or depression, or at the T wave. We will look at these elements in later videos. In the meantime, please use common sense. Watching a YouTube video does not make you an expert, so if you're taking an ECG, make sure that someone looks at it who's competent in interpretation. If you found this video useful, let me know in the comment section below.